Good morning or afternoon, depending when you're doing this. We today will be doing our final review before you work on your project. Today we're going to be looking at repeating decimals. Yesterday we looked at rational, irrational. Today we're going to be focusing on rational numbers, like we did last week, specifically repeating and terminating decimals. Trying to understand some of the intricacies of those kinds of numbers. So some big takeaways about repeating and terminating decimals. First of all repeating decimals are rational because they can be converted to fractions. Second, the length of a decimal does not indicate its value. For example, 0.12678 is not bigger than 0.9 just because it has more digits, because it's all about the place value, right? You have 9/10 versus 1/10. These place values don't have much value at all. I could write this as 0.9000. It doesn't change the number, but you can see it's much bigger. It's significantly bigger than this. So the length of a decimal does not indicate its value. Number three, changing a repeating decimal to an exact fraction cannot be done using place value because normally we convert 0.25 to a fraction simply by saying it's 25 hundredths. You can't do that with something like 0.333333333 because where does it end, right? There is no place value that it ends. So the only way to do that is the method that we did last week, which is using a system of equations. And then finally, there is a trick, as we saw last Thursday, there is a trick to getting some of the repeating decimals to fractions quickly, and we'll see that a little bit today. We're going to do 3 problems, and I'm going to have you try 3 and see what you can do. So think about what are 3 major takeaways about repeating and terminating decimals that you can put into your project. So first, we're going to look at this problem and see what I did with it. All right, so this problem has asked us to compare 6.25 repeating and 25 fourths. So let's start with 25 fourths first, because that's something we're used to, right? 4 goes into 25 6 times. There's 1 left over. That's 6 1/4. We know 1/4 is 0.25, so that's 6.25. It's a terminating decimal, so we know the next digit is 0. So 25 fourths is 6.250. 6.25 repeating. Now, the trick we learned last week is that when a number repeats, you use the same idea of place value. So this is 25 hundredths, but since it repeats, I change the 100 denominator, I decrease it by 1 and make it 99. So this is 6 and 25, 6.252525, and I could write that as 6 and 25 99ths. So right away, it starts to look like this is not the same thing as this, all right? In order to understand that place value, what's happening is this is 6.2525, so on, so on, so on. This is 6.250. These numbers are ridiculously close, right? The 6's are the same. The 2's are the same. The hundredths place, the 5's are the same. It's not until you get to the thousandths place that you see any difference at all. So this is 2 thousandths bigger than this. Almost no difference in most of our lives, unless you get into certain sciences or medicine. There's really no difference between these 2 numbers. They're essentially the same, but they are not equivalent. This is a tiny bit bigger. This is 2 thousandths bigger than this, but they're not equivalent. All right, so here's a problem for you to try. See if you can look at it and see if you can figure out who has the correct fraction, just kind of based on what you understand about how these improper fractions work. 2.15 repeating as a fraction. Daya had 97/45. Leo had 97/5. Who had the right one? And describe a mistake that person might have had. And I'll look at your answer on Edpuzzle. All right, here's the second problem. What fractions are equivalent to 1 and 27 hundredths repeating? 1.27272727. How do you figure that out? Well, let's look at it. So we're trying to figure out what is 1.27 repeating. What is that equivalent to? They give us a bunch of fractions. We're trying to figure out which one. First of all, it's important to note that that is not the same thing as 1 and 27 over 100, because that would be 1.270, right? This is 1.272727, and so on. You can write that as 1 in 27 over 99 because it repeats, and that's that little trick. Instead of 1 in 27 over 100, to make it repeat, you decrease that denominator by 1. Well, 1 in 27 over 99 was not one of my choices, so I converted to an improper fraction because they were all improper fractions. And 1 times 99 is 99, plus 27 is 126 over 99. So this is equivalent to this is equivalent to this. Remember, this is not equivalent to this. It's very close. But this is exactly equivalent to this, exactly equivalent to this. But this wasn't one of my choices. But then I realized 3 goes into both of these. So I basically divide by 1. 3 divided by 3 is 1. And if I divide by 1, I don't change the value. So 126 divided by 3 is 42. 99 divided by 3 is 33. And there is an answer choice, 42 over 33. So that is one of the choices. But then I say, wait a minute, 3 goes into both of these. 3 goes into 42 14 times, and 3 goes into 33 11 times. Again, I just divided by 1, 3 over 3, and I got 14 over 11. And that's another choice. Then I realized nothing else goes into that, so there's no other possibilities. 42 over 3, 33, and 14 over 11 are my 2 answer choices for that problem. All right, now you try this problem. See what you can do. It says Frank uses a calculator to convert degrees Fahrenheit to degrees Celsius. The online calculator says the temperature is 23.8, repeating 23.8888. What would that be as a fraction in simplest form based on what we just did? See if you can figure out the right answer. All right, now problem number 3. Last problem that I'll show you. Here are some decimals. Here are some fractions. We got to try to match which one goes with which. Let's see if we can figure that out. All right, for this problem, I had to try to match the decimals with the appropriate fraction. Now, at first, this seems crazy. Like 14 over 33, how the heck am I supposed to know what that is? 23 over 111, I don't know, right? But then you look at some of the choices here. 14 over 33, well, that's less than 1, right? That's 0 point something. 23 over 111, that's 0 point something. 114 over 111, that's a little bit more than 1. So that stands out to me. That's a little bit more than 1. 223 over 33, that's a lot more than 1, right? I don't know how many times 33 goes into 223, but I know this is bigger than 1 because it's an improper fraction. Then I look at 47 over 999. I don't know, but that's less than 1. 125 over 33, that's less than 1. So all of these are less than 1, 0 point something, except for these 2. So then I look at my choices over here. Well, this is bigger than 6, and this is a little bit bigger than 1. Wait a minute, a little bit bigger than 1. This is a little bit bigger than 1. That has to match. That means that this has to match this, because this is a lot bigger than 1. This is a lot bigger than 1. So this has to match this. Now I'm halfway done. Now, if I was like on a high school entrance exam test or something at this point, you could either kind of guess or you could kick your mind into a little higher gear. So for this one, I know that little trick, 42 over 99, right? I could do 42 over 99 because it's 42 hundredths, but it repeats. So I change that to 99. I say 3 goes into both of those. 3 goes into 42 14 times. 3 goes into 99 33 times. There's 14 over 33. Now I got 1 left. And it's either going to be 23 over 111 or 125 over 333. Well, at this point you could guess, or you could kick your mind into super high gear and say 0.375 repeating is going to be 375. Instead of over 1,000, it would be over 999. And you say, wait a minute, 3 goes into both of those. 3 goes into that once, twice, with 1 left over, 125 over 333. Boom. And there's the last one. So using a little thinking, I didn't even have to worry about that repeating decimal stuff until I got here, because just some basic math, understanding fractions helped me understand that 6.75 had to be this one, and 1.027 repeating had to be that one.